class, and today is the last part of the last motion we are going to see. This is the continuation part of gravitation what we have studied from a previous class. What are the things we studied under gravitation? We came to know what you mean by Newton's universal law of gravitation, and also we have studied about what you mean by force of gravity, then what is acceleration due to gravity, and what is the relationship between that of acceleration due to gravity and force of gravity. All those are very, very important. So whatever we are going to discuss in today's class also is a very important part of gravitation that we are going to explain. The first concept is what you mean by free fall. You know that very well. What do you mean by free fall? Just when we climb somewhere on a top of floor and just if we jump, it's considered to be a free fall, right? So see, it's very easy that when you fall from height, you will reach the earth. What is the reason by that? Earth is applying force against the force of gravity. But can you, in the same way, can you jump till second floor? No, you are not at all able to do. Only you are able to do that with some parachute or some of the equipments you can use and go like that. Other than that, can you be able to fly? It's not at all possible. The reason is that the acceleration due to gravity means the force is applied by the earth is always towards upon us, towards downwards. Earth will be pulling us, so we are not able to fly. But we can fly right from the floor. Why? Until when? Until we reach the ground. So that's the concept of whatever we are seeing today. So among free fall, so whatever we have, the motion of a freely falling body, the motion of a freely falling body from a height or the motion of a body thrown vertically upwards from the surface of the earth is the one-dimension motion under gravity. In the motion in one dimension chapter we have studied what do you mean by motion in one dimension. If a body is keep on moving in a straight line path or a linear or translational path, it is considered to be motion in one dimension. Here also we are considering of the same thing. When it is considered to be a one-dimension motion under gravity, when a body is moving freely towards the earth or it is moving vertically upwards, both the situations are considered to be one-dimension motion under gravity. See here, the motion of a free-falling body from a height. See, if I take this chalk, when I release it, it is falling freely under gravity from a height, or the motion of a body thrown vertically upwards. Now, if I throw vertically upwards, it is going vertically upwards from the surface of the earth. Is the one-dimension motion under gravity? Very simple concept. The motion in one dimension is what? A body is being keep on moving in a linear or a translational path, right? Now, one thing we need to remember in this case is the acceleration of vertically falling body is always positive. What is the reason the acceleration? See, now I release this chalk from a height, it is being falling down. Why the acceleration is considered to be positive? Because it is coming towards the earth. Being earth is attracting it, and even this is also moving in the same direction. Means, for example, to say that, think this, the object is still falling towards the earth. It was before here at some height. Here, force is also acting whichwards. Here, the earth is pulling the object towards downwards, and the object is also falling where? Downwards. Right? Both object is also falling downwards, force is also applied downwards. Hence, we can tell the acceleration is considered to be positive. The acceleration is considered to be positive. The acceleration of the body going vertically upwards. Now, before it was here, if you consider this is the earth surface. If an object tries to go, it was here. When I push what the object is trying to go upwards, means the force is acting downwards. But object is moving whichwards? The displacement. The displacement of the object is in the just opposite direction of the. Then the acceleration is considered to be negative. Did you understand? In this case, here the initial velocity was 0 at some height. When it releases, it had come to the earth surface. In this case, acceleration is considered to be positive. Whatever the object which is being coming towards the earth, its acceleration is also always positive. Remember this, acceleration due to gravity is always positive. But if any object which is going away from the earth, just opposite direction of the earth, then always remember the acceleration due to gravity of that is always negative. Understand? I know that you hope this concept is very much clear, because since from motion in one dimension we are studying of the same thing. Now let me tell you that we need to remember the equations of motion. Equations of motion. What are the equations of motion we studied in motion in one dimension? So those are, if you recall, we know that V is equals to U plus AT. Correct? Next, second one is ready. S is equals to UT plus half AT square. This is the second equation of motion. And last one is V square is equals to U square plus AS. These three equations of motion we studied in motion in one dimension chapter. That is when a body is moving in a linear or a translational motion. These are the three equations of motion comes into picture. That is V final velocity, U initial velocity, A acceleration, T time, S displacement. Then whatever else we have, this everything is being studied. Understand? These are the decoding terms. What do you mean by V, U, or T? Now we are studying under free fall. The same equation of motion, when we are studying one dimension motion under gravity, when we are studying one dimension motion under gravity, there is slight change in this equation of motion. There is slight change in the equation of motion. What are those changes? Let me see now. This first equation is called V is equals to U plus GT. Instead of A, I take G. The reason is, it was A acceleration in that case. For example, we was considering some object keep on moving, it was having velocity, it is having change in velocity, gives us what? Gives us acceleration. So these equations are valid there. But here, we are speaking of what acceleration? Acceleration due to gravity. Here we are speaking only of Earth's concept. That is, it is not only an acceleration, it is acceleration due to gravity. Hence the equation becomes U plus GT. By this time you might have understood. Instead of A, we will go for what is the term called G. Here A is only acceleration. Here G means acceleration due to gravity. What it is? Acceleration due to gravity. That's the only change. So that equation never changes. What is the second equation? We know S is equals to UT plus half AT square, right? So here instead of S, that is displacement, we can consider to be height. That is what, right? So if an object is going upwards, we can measure it as height. No doubt it is a displacement, but here we will consider to be what? Height. Means displacement becomes height. H is equals to UT plus half GT square. These are the equations of motion under gravity. Equation of motion under gravity. Then what will be the last one? Last one will be V square is equals to U square plus 2Vs. Understand? The only change is wherever displacement there is an height, where is an acceleration, there is acceleration due to gravity. Understand? In a case of free fall and gravitation, we consider these three are the equations of motion under free fall gravity. Understand? I hope we have understood now. Now we will consider some of two cases. When you have seen that in this equation of motion, when it is considered to be positive, when initial velocity is 0, equations become U is equals to AT, all those considered. When final velocity becomes 0, what happens to the equations? We will quickly see now. We will see two cases in the case of free fall. What happens to the equations of motion under gravity? See, let us consider case 1. If a body falls from rest freely from a height h, consider a body, something like a ball, consider a ball. If a body falls from rest, before it was rest here, freely from a height h under gravity, then u is equals to 0. That is, its initial velocity is how much here? 0. It has been falling freely under gravity. Right? After that it reaches here. Then acceleration is replaced by g. When it is falling, the acceleration is considered to be g. The reason is it is an acceleration due to gravity. So now what happens to the equation of motion? See, we already know the equations of motion of this car. U is equals to u plus gt. Then we studied the other one is h is equals to ut plus half gt square. Then v square is equals to u square plus 2a h. Sorry, I think in the previous one I have written s only. Please change it to h. Because here distance is considered to be what you mean by h. It is having an height h. Okay, which has been falling freely down. So in this situation, first the initial velocity is considered to be what? Initial velocity is 0. The reason is body in this position is at rest. So its initial velocity is how much? 0. Then what happens to these equations of motion? In this situation, when if a body falls from rest freely from a height h, when it is falling. Now for example, this chalk is being falling down. Means consider it is a chalk which is freely falling under gravity. Before, when I am catching here, its initial velocity is all 0. Then what happens to these equations of motion? What happens to these equations of motion are, I can just write, instead of putting 0 everywhere, we can directly write u is equals to gt, right? Then h is equals to half gt square. Then v square is equals to 2, oh sorry, see here also I can write g, 2gh. These are the three equations of motion under gravity when initial velocity is 0. Remember why this is in the numericals. When you are doing numericals, we can make use of these equations of motion directly. You have done this in the case of motion in coordination. The same equation of motion we are studying under free fall, under gravitation. Why? Because it is a motion in one dimension under gravity. Now we will see some case 2. If a body is thrown vertically up, now the just opposite situation to this. Think about it before it was here. Consider a ball which is being thrown up now. Which is being throwing up. Consider it reaches. With the initial velocity u, it was having initial velocity to be u. Some value, because I am not giving it. To a height h, the distance is equal to h, and there will be retardation. Obviously, why here it is retardation? Because negative acceleration. Here body is coming towards the earth, so positive acceleration. Before we have studied. Now if the ball goes in the opposite direction of earth, remember its acceleration is negative. That is minus g. Negative acceleration in the world, what it is studying motion in one dimension. That is retardation. Then what happens to this equation of motion? Let us see. What are the equations of motion? V is equals to u plus gt. Right. Then we have h is equals to ut plus half gt square. Then we have v square is equals to u square plus 2gh. This equation becomes, now we have acceleration is negative, but initial velocity has a value. So this becomes v is equals to u minus g. Why it became minus here? The reason is this g is having a negative value. Understand? So v is equals to u minus gt. Then I have h is equals to ut minus half gt square. Then last one I have v square is equals to u square minus 2gh. Understand? These two cases It was already known to you, but again in a very detailed way I have been explained. Remember, when a body is falling towards the acceleration is positive, and these are the equations of motion. Then if a body is slightly moving up from the earth's surface, it is having negative acceleration. And these are the three equations of that motion. So I hope you have understood what is the concept of free fall. Now we will discuss what you mean by mass, weight, its CGS unit, gravitational units. Many things are there to learn the basic in 9th standard. We will see now. We have the concept called as what you mean by mass and weight. Every time we will be having studied the mass and weight. What is the difference between this? Today we will clearly learn about this. Now see, what do you mean by mass? If they ask you is, the mass of a body is the quantity of matter it contains. You know already matter. What do you mean by matter? Every object is having a matter. Number of you have studied in chemistry like solid, liquid, it has a matter, mass and all these things, right? Mass, it has mass and occupies space, we will tell for a matter. Have you ever learned that? What it is, the mass of a body is a quantity of matter it contains. That's all. This is the definition of mass. Then what is a mass? It is a scalar quantity. Remember, mass doesn't have any direction. Hence we call it as a scalar quantity. We already studied in motion equalization chapter, and even in the case of physical quantity and measurement first chapter. SI unit of mass is what? Kilogram. And what is about its CGS unit? CGS unit is gram. See, it is constant for, this is a very important one. It is constant for a given body at rest and does not change from changing the place. See, if a body is at rest also, in motion also, what happens? Its mass does not change. Mass remains constant. Even it changes from place to place. Whatever it is in Bangalore, it will be the same mass. It will be in Hyderabad or Jammu Kashmir or Antarctica, everywhere, wherever you take. Understand? Mass does not change from place to place. Remember this. So what do you mean by mass? Mass of the body is a quantity of matter it contains. What is the matter? Matter is which has an object has a matter which has mass. We have studied, right? Then this is about a quick recap of what you mean by mass. These are the important points you need to remember regarding mass. Now when we study weight, you will understand what is the difference between that of mass and weight. So what do you mean by weight? The weight of a body is the force with which the earth attracts it. The force with which the earth attracts it. This is called as weight. See, for example, some object is there. Everything is having a mass, right? So earth, what happens? It applies a force on it and attracts towards its center. That we studied in what you mean by force of gravity. What is the equation of force of gravity? That is G mf by r square. Capital R square. This is mass of an earth. This is gravitational constant. This is mass of a body which is here. That is 1 kg we have taken, and we have taken the radius of earth, and we have found out what is the force of an earth on us. It comes nearly 9.8 Newton per meter. Understand? So this is what the weight. Whatever the force which is being applied on us is the weight of the earth. That is what, if we tell our weight, it is what? It is plus mass into the weight which is being, the force which is being applied by earth on us is together called as what we mean by weight. Remember this. The weight of a body is the force with which the earth attracts it. The weight is the vector quantity. Remember, see, if I tell weight is a vector quantity, obviously it has direction. See, the direction is towards the center of the earth. This direction, how can we tell? See, earth is being very huge one. It attracts every particle in the universe towards it. Every particle on the earth, it attracts towards its center. Understand? So we will tell the weight as a direction. What is the direction of the weight? Towards the earth, towards the center of the earth. We can tell. Now, what is its SI unit? SI unit of weight, remember this is Newton. Like a force, even weight has a same SI unit, that is Newton. CGS unit is dyne. Remember, when you are writing completely Newton, you have to write everything in a small letters. Since it is a unit, when you are denoting it, we have to write in capital letter. Keep remember this. Here, like English doesn't come. Like a name of a person, place, it should be there. The noun doesn't come under here. When you read a unit, it should be always written. If you want much information, read the guidelines given in measurement and experimentation. Guidelines we are followed to use a unit. You will come to know. And we also learned a relationship between that is. What is the relationship between SI and CGS unit of force and weight? 1 Newton is equals to 10 to the power of 5. Even I myself proved to you that. Even in your 10th standard again, we get those. I hope you have understood first what you mean by mass and weight completely. It is scalar, it is a vector. See, very important question is give the differences between mass and weight they will give you. Understand? So you can give any of the differences as you know. But still the concept of mass and weight is behind. Now I need to explain what you mean by the relationship between the mass and weight. And we will come to know this last point. That is mass does not change from place to place or when it is at rest. But what about weight? We will see. And now we will continue with further the units. There are many gravitational units we need to study. That also we will see now. Now we have the relationship between mass and weight. How the mass and weight are related together. Remember, weight is equals to mass into acceleration due to gravity. That is, if you want to calculate the weight is always a product of mass and acceleration due to gravity. That is what our weight. See, if I know that, for example, if our weight is 80 kg, 60 kg, anything, means how did we manage this? This is your mass and the force which is being applied by you on the other on you gives you the total weight. Understand? This is very, very important. See, since the value of G varies from place to place. For example, you consider to the at pole and equators, the value of G varies. Means your weight changes from place to place. If you will 80 kg in Bangalore, it may not be the same in Jammu and Kashmir when you go. The reason is that, or just an example like that, because the value of G, that is acceleration due to gravity, changes from place to place. But mass never changes. Wherever you are, mass remains the same. Remember, since the value of G varies from place to place, the weight of a body also varies from place to place. This is a very important concept you should be knowing regarding the weight. So what is the relationship between weight and mass? It is m into G. I hope you are understanding this. And last we have what we mean by gravitational unit of weight. What is the gravitational unit of weight? See, very, very important. In 10th standard again you will get this. So what are the gravitational units of weight are? In SI or MK system, the gravitational unit of weight is kilogram force. We will tell what you mean by kilogram force. Shortly we can write as kg of. Kg of for a kilogram force is a gravitational unit of force in SI or MK system. This MK system has only become the SI unit. MKS units are only the SI units maximum. In CGS system, if we call SI kilogram, it becomes gram force. This is the CGS system. Gravitational unit of weight in CGS system is gram force. And how are they related? Is 1 kilogram force is 9.8 Newton. It's a value of 9.8 Newton. That is 1 kilogram force. What is the relationship between gravitational unit of force and SI unit of force? How the both are related? That is 1 kilogram force is equals to 9.8 Newton and 1 gram force is equals to 980 Newton. This is very, very important, these relations. And along with this in your textbook they have given gravitational unit of force. I have made you to study gravitational unit of weight. In your textbook they have given gravitational unit of force also. Everything they has given. Now I am not going to explain that. That's a very simple one. It comes again kilogram force, gram force only. The same relation. 1 gram force is 980 and 1 kilogram force is 9.8 Newton. The same thing is there in your textbook. After taking the notes till here, please follow. You yourself can go through that and copy that from your textbook. Understand? So I am not going to explain you now. That it's a very simple one. I have already explained you. So you can write it. So that winds up your chapter. What you mean by laws of motion. So it's up to your duty to write all the question and answers for this and submit me and all the very best for your unit test too. See, there is no gap between test 2 and a semester exam. It's almost within a year. So it's up to you to that. You have to completely read what you mean by motion in one dimension and even laws of motion. Lot of questions will be going to appear from these 2 big chapters. These both are the 2 big chapters. So I hope you will study until next class.